This video accompanies what I call the Molarity Toolkit and introduces you to the simple path to stoichiometry calculations and a new path into the mole hole. Why do most students find stoichiometry difficult, even scary? Well, you measure out the grams of one reactant, then you measure out the grams of the other reactant, you react them. You separate out any excess reactant and you identify the product. You get the mass of the product, you find the moles of the limiting reactant that was used, you find the moles of the product, and then you can write the chemical equation and do further calculations. And to this rather elaborate process, at any given point you can make a mistake. Most students say, yuck. Now, what if it were a lot easier? You measure the volume of reactant 1, not the mass, the volume of reactant 2. You react and know that there's no excess of either. You calculate the moles of each with one simple multiplication. Wouldn't you rather do it this way? Isn't stoichiometry looking a lot simpler with this? Well, here's what volume stoichiometry depends on. In a true water solution, the contents of each milliliter of the solution, say up here, would be the same as the contents of any other milliliter down here. We call that what? Yeah, you remember that from back in the first unit. When you have something that is a true solution, what kind of mixture it is. So, if you know the concentration, how much is in each volume, each milliliter, each liter, then if you know the volume, you know the number of moles. Moles equals molarity times volume. The Molarity Toolkit will help you to work with moles or millimoles, grams, volume of solution, in liters or milliliters, and of course molarity. And we simply go by the definition. The molarity of a solution is the number of moles of solute in a liter of solution. But also keep in mind that this calculation here is not only a definition, but it's also the method of doing the numbers. And keep in mind that the molarity is also the number of millimoles of solute in a milliliter of solution. And whether you're expressing it in moles per liter or millimoles per milliliter, the numbers are the same. A 2 molar solution of something is 2 moles in a liter or 2 millimoles in a milliliter. Let's do review tools A. How many grams of sodium hydroxide are in 3 moles of sodium hydroxide? Well, you know that. Find the mass of a mole of sodium hydroxide from the periodic table. Add them up, you get 40 grams in a mole. And you set up your equation. The mass is equal to 3 moles times the ratio. These things are equal. 40 grams of sodium hydroxide is 1 mole, and therefore 120 grams. Probably 2 significant digits here. Review tools B. How many moles of KCl are in 14.9 grams? This is just a review of something you've been doing perhaps for months. First, you find the mass of a mole of KCl from the periodic table. There's the molar mass. Add them up, 74.6 grams in a mole. Then set up the equation. Moles equals 14.9 grams you're given times the ratio 1 mole of KCl per 74.6 grams. You do the division. The answer is 0.200 moles. 3 significant digits. The second thing we'll look at is finding molarity for moles of solute and liters of solution. You simply go to the definition. 2 definitions here give you the same number. Example, what is the molarity of a solution with 0.650 moles of HCl into 0.3 liters of solution? You simply divide the 0.650 moles of HCl by the volume of the solution, 2.3 liters, and you get 0.28 moles in a liter, or 0.28 capital M, 0.28 molar, 2 significant digits. Next, moles of solute in reaction from the molarity and the volume of solution. Well, if we know from the definition this fact, then we simply multiply both sides by the volume. And so moles of solute is molarity times liters, or millimoles of solute is molarity times milliliters of solution. Example, how many millimoles of sodium hydroxide have reacted? If 32 milliliters of 0.4 molar solution react, you simply find the millimoles of sodium hydroxide by multiplying molarity in milliliters. You should really write millimoles per milliliter instead of the capital M. The answer then is 12.8 millimoles. Next skill, volume given moles and molarity. We start with the definition. We then find liters of solution must be equal to moles of solute divided by molarity, or millimoles of solute divided by molarity. So what volume of 0.350 molar H2SO4 contains 25 millimoles? Well, the milliliters of solution. Then the volume, here, milliliters, equals 25 millimoles divided by the molarity, which again we should write as millimoles per milliliter. Do the division, we get 71.4 milliliters, 3 significant digits.